Um, we started last week talking about evolution and the theory of life, and we went into a description of what the theory of evolution was that Darwin proposed, and then we started talking about the evidence that shows that it couldn't possibly have happened that way. And we went into and talked about DNA, both for animals and humans, and talked about the fact that in Darwin's time, the existence of DNA wasn't even known. It wasn't even discovered until 1860s. And the structure of it, the sheer complexity of it, wasn't discovered until 1953. And then it's only recently we've really understood how a lot of it works, and there's still some things we don't understand. So we're going to continue from there. And so like I said, we saw a couple videos last time. One was just a description of how DNA, what is it and how does it work, and it's basically a chemical system that makes proteins in our body. And then I showed another video that showed how DNA reproduces itself and how it corrects errors, and that process was really not understood until fairly recently, and the people that discovered it won the Nobel Prize in 2015. And in fact, most of the Nobel Prizes in medicine for the last 20 years or so have been associated in some way with DNA. You may have seen that the recent one, which was announced about a week ago, was for mRNA, or the messenger RNA that has to do with DNA. So just as time goes on, we're discovering more and more about the complexity of DNA, and it just goes further to show that, life itself was not an accident. So we're going to talk a little bit more about that. What's interesting is the people that are most closely associated with DNA and understand the marvels of it are kind of split. They're either devoutly Christian or they're militant atheists. So Watson and Crick, who discovered DNA and were very close to it, are militant atheists that were till the end of their life, and they had some pretty nasty things to say about Christianity. So Crick said that the God hypothesis is rather discredited. Indeed, my distaste for religion was one of the prime motives for my work. And then Watson had to say religious explanations were myths from the past. Just kind of, for me, it's kind of hard to understand how they can see this incredible complexity and the beauty of what they're working on and just miss the fact that it had to be created. So, go on a little bit from where we were at. I'm not going to, we talked about DNA, and it consists of 3.1 billion strands or ladders in a spiral network. What's interesting is that the density of the memory in DNA is so incredibly tight that the semiconductor people now who are making memories for computers are trying to duplicate the way DNA stores energy or stores memory. Right now, the density that DNA represents for memory storage is over 1 million times denser than the most complicated processes that humans can devise. And in fact, if you took all the information in all the world, which would be an enormous amount, it fit in less than a coffee cup in volume if it had the same density as DNA.
Wow.
So. The other thing that's interesting is I showed you a video last time about the replication or the gestation of a baby chicken. And it shows the formation initially hour by hour, and then minute by minute, hour by hour, and then day by day. And it's truly amazing, and that entire process is governed by DNA chemical processes. It's just truly amazing, and it's just, like I said, it's amazing. So each cell, it has basically, the DNA is kind of like a controlling computer in each cell with this 3.1 gigabyte or 3.1 billion strands of ladders in it. And if you compare that to something you might know, an iPhone computer, the computer in an iPhone, when you're talking on the iPhone, it draws about a watt of energy, and if you're not doing anything with it, it's about a milliwatt or a thousandth of a watt in the lowest power state. Okay, so if you compare that with the DNA computer that's in your cell, you have 20 trillion cells in your body. And if you took and said, well, each of those cells, if it were to dissipate the minimum power of an Apple computer's core, which was a milliwatt, your body would be using 20 billion watts of energy, which, to put it in perspective, that's about half of the energy output of all the electrical plants in the state of Missouri, okay, for one person. Okay, so truly amazing. It's incredibly energy efficient, and it's all chemical. So there's an example, the ARM computer core in the human cell with the DNA in the center. Now, we talked a little bit last time about the structure of life and how it's made up of amino acids and proteins and things. And we talked a little bit about how likely is it that the proteins required for life could have been generated by random mixtures of chemicals, and it wound up to be an astronomical number, saying that it was possible. So now let's take a look at DNA, and let's just say that you know what the basic building blocks of DNA are. You have a jar of proteins and a jar of amino acid molecules, and you kind of mix them all together. How likely is it that you could find that by accident? Okay. So the chances that if you mix through things in a jar and you just mix them up, again, knowing what the elements of the recipe are, and finding having life result from that would be like throwing an honest coin 80 million times and getting heads each time. Okay. Now let me put that in perspective for you. If you were going to do this 1 million times a second, you'd have to repeat it for 30 sextillion years to have a 50% chance of duplicating life. So that's 30 billion trillion years. Okay. So it's impossible.
Yeah.
And that's just knowing up front what the elements are, and if you're going to create it at random, it'd be much more unlikely because you have to start from scratch. So it's just amazing. So there's a guy, our mixer is going to be pretty disappointed here. I'm not going to show this video again. I showed this to you last week. This is the one where the egg sequences from fertilization through the development, and they've used imaging techniques to record all the processes involved. And this is just an example of what DNA does. It controls that entire process. And there are many elements of that which we don't know anything about. We don't know how the different cells communicate with each other, how the DNA of one cell tells another one, you're going to be a heart muscle, you're going to be an ear, you're going to be a foot. All that we really don't understand. So I'm going to skip that. And I didn't have a chance to talk about, there's an excellent DVD called Flight. I'm going to show you another thing about, it's a great thing about nature and aspects of nature that show or there is a God. So now I'm going to get back to the evolution thing again. And the basic premise of Darwin's theory is that somehow life started in a single-cell organism. And then, over time, that single-cell organism mutated to a multi-cell organism, and those multi-cell organisms became different life forms, and they eventually became rabbits and weasels and birds and whales and fish. Okay, we're gonna talk a little bit about that right now. First of all, we're going to talk about microevolution. If you recall, Darwin did a lot of studies in a voyage that he took around the world that lasted 5 years. And he noticed that there were a lot of birds in the Galapagos Islands that were very similar, but they had different beaks, and depending on what they ate, they had a different beak structure. And the turtles around the world had different necks and slightly different feet and whatever. He said, "Wow, this proves evolution took place because all these things are, from a common element." But what they really are something called microevolution, and that is they're very small changes within a species that change some characteristic of the species, color, height, or whatever, but it's still the same animal. Okay. So the birds that Darwin worked on and used as a basis of his part of his study were all birds. Okay, there was no example there of a bird becoming a turtle or whatever. So this small change within a species is called microevolution. It's been proven. Moths can become different colors depending on their environment. Giraffes get longer necks over time if the trees get to be taller and things like that. Those have been observed, and they're real. The thing about Darwin's theory that has not been proven, and based on DNA and other things, it's impossible with a random process, is one species changing over time and becoming something else. Okay, so again, turtles don't become rabbits and things like that. So microevolution is the appearance or disappearance of some trait that within a species. It can be color, various things that we talked about, and that's been very well proven, and there's lots of examples of that. And the examples are the finches that Darwin observed, moths and various insects can develop resistance to pesticides and things. So those are very well known. And they are all involve the loss or sorting of some minor level of genetic information. So that birds with different beaks are still birds. Dogs that are bred into other animals are dogs. They're not horses. And the evolution of horses, they're still horses, although they started out very small. So that element of Darwin is not right. I mean, it's not proven. So, and again, the things that have not been seen is, first of all, he made this argument. Last week we talked about GODU, where pond scum could become single-cell animals, and eventually they all migrated and mutated and eventually became us. Okay, there's no evidence that that's possible. There's no evidence that has happened. So the common descent thing that he argued about is not happened. The emergence of new advanced species by mutations and natural selection has not been observed. Especially, we're going to talk about the fossil records. There's just no evidence that that's ever happened. And again, the DNA characteristics that we're beginning to understand say that's not possible. So the summary is that macroevolution has not been and is not being observed anywhere. Again, the goo to you evolution is mathematically impossible based on DNA, and everybody say, even the evolutionists say that they should see these transition forms. If single cell to multi-cell creature, single cell became multi-cell and invertebrate became vertebrate or whatever, there should be some intermediate forms that we're not seeing. And all the missing links that they're called are still missing. And there's some pretty significant evidence that they don't exist. One is there's something called the Cambrian explosion, which happened about 540 million years ago. There was a period of about 55 million years in which there was a sudden explosion in the number of fossils found in the fossil records. If you recall, the fossils are deposited in layers, and in each layer there are increasingly complex animals and life forms as you go up, which is consistent with what the Bible had to say about God creating simple things first and then more complex things. But that same fossil record that preserved all of those new animals that shows no evidence at all of intermediate life forms. And what's important there is that's the period when in the seabed and the sea life, the first hard-shelled critters emerged, and they fossilized really well. So there's an incredible fossil record of all these shelled animals or shelled life forms, and nothing in between. There's nothing that shows the critter halfway to a shelled animal or whatever. So that's important because that's just missing. And there were literally hundreds of thousands of new species that appeared in a very short time. And the other thing we're going to talk about is because of the mathematical odds against mutation, if mutation did occur, it would take a very, very long time, billions of years. And in this relatively short period of time, 50 million years, there were all these new creatures that appeared, so it's very strong evidence against evolution. And again, they were readily fossilized, and there's no sign of any intermediate form. So the evolutionary biologists now are circling the wagons a little bit, and they're a little bit frustrated in that there's been no transitional forms have been found. So now they've put some hypothesis in place that says, well, maybe evolution goes in bursts, and these new things, we're just not seeing them. The other is, well, there's no intermediate forms shown because those animals snuck away and hid somewhere. Okay, there's no explanation. How could they? They'd still die and be somewhere, and we've never found them. So it's kind of stretching the thing a little bit. Just to talk a little bit about random mutations. This is an area of intense discussion with biologists and evolutionary people. The data is a little bit obtuse and hard. It gets very complicated mathematically, but just to give you some idea of what happens is the DNA of even the simplest animal has hundreds of millions of chemical pairs in the DNA structure. And to create a new species, you have to change minimum 10, 20 million of those pairs of chemical bonds. And it doesn't, and not only that, but if it's going to mutate to a new species, it has to be repeatable and picked up by other generations and things. So the rate at which that can happen is very small. It's like between 1 in 100,000, 1 in 10,000 and 1 in 10 million, roughly. So if you were to take, and of that, only 0.01% of the mutations are deemed to be beneficial, that could benefit with an increased complexity. So if you take the math, it turns out that for an organism that lived 1 year and which had a very significant population, a beneficial mutation occurs only once in 1 billion to 100 billion years, and it's way too long for evolution to occur in some of these time frames you're talking about. So bottom line is the math and the biology of DNA makes it incredibly difficult for beneficial mutations to occur. So this is one of my favorite quotes from a guy who's not a Christian or anything. He's just a phys scientist, and he says, well, as common sense would suggest, the Darwinian theory is correct in the small but not in the large. Rabbits comes from other slightly different rabbits, not from either primeval soup or potatoes. Okay. And that's not a surprise, okay? Yeah. That's why we know dinosaurs today. So another thing, and I won't get into this again, it gets to be an esoteric science argument, but there's something called the second law of thermodynamics that says if you leave something by itself, it doesn't get more complicated. It tends to degenerate, to become less organized.
It's like your hair in the morning.
Yeah.
There you go.
So evolution requires just the opposite. It says things are getting more organized by themselves without, and that's a little bit hard. The way I like to put it is cars don't rust into new cars. Okay.
Too bad. Yeah.
Something that is important is what's called the irreducible complexity. Okay. There are a lot of very, very complex things in nature. We're going to look at a few of them. And there's a pretty strong argument that a random process could not generate those structures in any reasonable time. Okay. So let me give you an example. One of the classic ones, if you look in a apologetics book or something, they usually talk about a mousetrap. Okay, and I don't think it's the best example, but we'll talk about it because that's what you'll find. So one of the examples here, the purpose of this is to say that a mousetrap doesn't function unless you have all the pieces. Okay, so you have to have something that, you have to have a place for the bait, you have to have a trigger, that you have to have a bar that, or something that kills the mouse if he nibbles on the bait, and a release mechanism and all that. So if you don't have all those pieces, you don't have a mousetrap and it doesn't work. Okay. And if you remove any one piece or it's missing, it doesn't work. Okay. So let's move away from that and talk about eyesight for a minute. Okay. Human eye is incredibly complex. It has a lens system that takes incoming light and focuses it on a retina and the back. It has very complex mechanisms for adjusting to the level of light, so you can see and everything from darkness in this room to bright sunlight. And not only that, but there's an optic nerve that couples to your brain, and your brain has the ability to take the signals that come from your eye and interpret them and say, wow, that's a chair, or that's a TV set, or whatever. Okay. So the eyesight mechanism doesn't work if any one of those pieces is missing. Okay. If you don't have an opening where it focuses the light in, it's not going to work. If you don't have a way to sense the light, it's not going to work. If you don't have a mechanism for taking the output from the light sensor into the brain, it's not going to work. And if your brain can't process the information it gets, it doesn't work. So all that means is, in the theory of evolution, the proposal is that features that enhance the survivability of the creature are allow that creature to survive in very tough environments. So it's the survival of the fittest. But if any one of those elements is missing or not working, it has no impact on the survival of the element, or the survival of the creature. Okay, so that raises the question: how in the world did eyesight develop in the first place? Okay, if parts of it formed to the brain and the eye mechanism was not there, it wouldn't work. If the brain was underdeveloped or couldn't process that signal, it would not work. So there's all kinds of things missing here, and what's interesting is, if you look at what Darwin himself in his book said, to suppose that the eye, with all of its inimitable contrivances for adjusting the focus to different distances, for emitting different amounts of light, and for the correcting of spherical and chromatic aberration, could have been formed by natural selection, seems, I freely confess, absurd. Okay. And he left out some things. He left the part about the brain connection and the optic nerves, all of this stuff. So it's just amazing. Now another illustration of why, of critical complexity and why they could not evolve by evolution in the way we understand it, is birds and the ability to fly. Okay, so birds, it turns out, have a lot of very special structural elements. In order to fly, they have to be lightweight, and it turns out that birds have hollow bones, and they have reinforcing structures in their body, in the elements of their body, the bones that form their body, that resemble the way we build reinforced bridges today. Okay, so they have very special structural elements in their body. Their muscles have to be much, much stronger than the muscles in land animals or other things, because they have to flap wings very strong. They need a much improved cardiovascular system, because it takes so much energy to fly, so you have to circulate blood better and whatever. And then the wings have to be coated with things that are flexible and yet can push on air, and it turns out there are features of wings of birds that were just recently discovered. And if you've ever been, if you've noticed the airplanes these days, at the tip of the wings, they're bent up just a little bit. They found that by looking at the way hawks fly, and it eliminates some of the turbulence. So I'm going to show you this video, and we'll go from here.
If you think about flight as a behavior, it's really an all or nothing proposition. You don't partly fly, because flight requires not just having a pair of wings, but having your entire biology coordinated towards that function.
Avian flight hinges on a critical balance of aerodynamic design, physical strength, and minimal weight. And every part of a bird's anatomy helps fulfill these criteria.
This is a remarkable
balance that the bird has to maintain between structural strength of the bone and the needs for flight.
In order to fly, a bird must be strong enough to free its body from the bonds of gravity and light enough to remain suspended in the air. Its skeletal system is crucial to success. This adult pelican weighs more than 20 pounds and has the strength to fly hundreds of miles before landing. Yet its entire skeleton weighs less than 30 ounces. How? The majority of the bird's bones are hollow and reinforced by an internal network of girders and struts. The result is a light but durable framework, able to withstand the constant stress of flapping, takeoffs, and landings.
Feathers do a lot of different things really, really well, and they're very specialized in the way they're designed.
Birds are covered by several types of feathers. Closest to the skin, a soft, thick coat of down provides excellent insulation. And the down is encased by multiple layers of contour and primary feathers. These outer layers give a bird its streamlined shape, protection from moisture, and the ability to maneuver freely in the air. To do so, they must be light, strong, and extremely flexible. When a Canadian goose approaches a pond, the long primary feathers on his wingtips bend and twist open like a Venetian blind. Simultaneously, the alula, 3 feathers attached to a small bone, is raised to create a slot that alters the path of turbulent air rushing over the wing. The precise actions of these mechanisms prevent stalling while slowing the bird's descent for a controlled, soft landing.
You're going to need specialized muscles to move those wings, so your pectoral muscles in particular are going to be very large.
Hundreds of muscles, tendons, and ligaments power a diverse range of wing movements. The centerpieces of this system are the flight muscles. Pectoralis major, and beneath it, supracoracoideus. Together, they form the engines of avian flight. When the pectoral muscles contract, they pull the humerus bone in each wing down, creating thrust and lift. In immediate response, the supracoracoideus, connected by a tendon to the top of the humerus, works like a pulley to lift the wing every time the muscle contracts.
This is another terrific design because this pulley system eliminates the need for a large, heavy muscle above the shoulder to lift the wing back up. Instead, the flight muscles are all below the wings, where they help create a compact center of gravity that really stabilizes the bird's body in the air.
Everything on a bird is integrated together so that flight is possible. Everything that possibly can be reduced in weight is reduced. Everything that can be moved towards the center of mass is moved. All of these engineering compromises, all of these refinements, it's multiple systems working together perfectly in a coordinated way all at once. And when you put that puzzle together, enough pieces fit in exactly the right way, then boom, you have the magic, and the birds can fly.